Hello, we're ready for part 2 of section 1, chapter 2, talking about polynomials. I'm going to jump right into the examples. A quadratic polynomial, p of x, has leading coefficient, I wrote coefficient 2 times there, has leading coefficient -2, has a constant term of 6, but no linear term. I want you to find the zeros of p of x. Alright, let's talk about all that information I just gave you. Alright, so if it's a quadratic polynomial, let's think about what that means. That means the highest power we're going to see is 2, x squared, which means we have 2 roots. Might want to write that down. We have 2 roots. Has a leading coefficient of -2. Leading coefficient of -2. A constant of 6. That means the term with no variable is 6, but it has no linear term. A linear term is the term that just contains x to the first power. That means 0 must be in front of it. That's the only thing that would make it disappear. So the generic form for a quadratic function is ax squared plus bx plus c. Tell me everything you know. Well, we know that ax squared, since it has a leading coefficient of -2, must read -2x squared. Ask yourself if you know where I got that from. Leading coefficient. Highest power of x must have a leading coefficient of -2. 0 has to be the coefficient of the linear term. And c has to be the constant. Well, that just says -2x squared plus 6. And if you're going to find the zeros of a function, then you should set it equal to 0. Because you're interested in when does y equal 0. Well, now you just solve. There's 2 ways you can do this. You can subtract 6 from both sides and divide by -2. So x squared is equal to 3. That means x could be plus or minus the square root of 3. We've got 2 real irrational roots. We could have also, right here, factored out a -2, which would have changed +6 into -3. Now, the -2 is negligible because when you divide by both sides, it disappears. And then you end up with the same answer again when you add 3 to both sides and take the square root. So, I love these kind of problems because they really tell me who knows the vocabulary and who doesn't. So pay close attention to the vocabulary. Okay, we're going to do something here. We're going to find p of -1 for this polynomial. That means substitute -1 everywhere you see an x. And we're going to do this by a process called direct substitution. That's where you directly insert -1 or whatever value for x you're interested in for x. So this will be 3 times -1 to the 4th power minus 7 times -1 to the 3rd power plus 5 times -1 squared minus 7. That becomes 3. Let's see here, negative, that's a +7 plus 5 because 2 negatives make a positive minus 7. Answer is 8. Therefore, p of -1 is 8. When you plug in -1, you get 8. -1, 8 would be an ordered pair on this graph. If you put it on your calculator, you would see -1, 8 in the table. But now I want to show you a process called synthetic substitution. It gets the same answer just through a different method. And what we do is we draw this little box, this little half box. And I never knew what this box was called when I was taking Algebra 2, so I just started calling it one day the hoopty. That right there is the hoopty, H-O-O-P-T-I. So if I ever say draw the hoopty, I want that half box. Hoopty. Okay? All right. I just made that up. You won't see that in your textbook. And then you put all of your coefficients. 3. -7, 5, and -7 again. Careful though, and you'll see why I'm talking about here in a second. So we put 3, -7, 5 from the x squared, 0, negative 7. Wait a minute. Where did that 0 come from? Where did that 0 come from right there? You know where it came from? Look back at your original problem. What are you missing? You're missing a linear term. I'm going to make a little note here. We're missing 0x. And when you do synthetic substitution, you have to account for each term. Then leave a little space, just like this. And what you do is you do 3 steps. Okay, you drop, that's step 1, and you drop the leading coefficient. So bring down the 3. Then what you do is you multiply, and you always multiply by the hoopty. So take the negative 1, it multiplies to 3, and this bounces up here. That's negative 3. Third step, you add. So you add negative 7 and negative 3, that's negative 10. Now, you multiply again. So steps 2 and 3, they repeat. That's how synthetic division or synthetic substitution works. So negative 10 times the hoopty, negative 1 is positive 10, and it bounces up here. 5 and 10 make 15. Then negative 1 and 15 multiply again, that's negative 15. 0 and negative 15 make negative 15. And then multiply by the hoopty one last time, negative 1 and negative 15 is positive 15. And add, and looky there, we get 8. That's the same thing we got when we did direct substitution. This is also called, just for giggles, write this down, that's called the remainder. When you divide the function by the factor x plus 1, for if negative 1 was what we were dividing by, the factor that we were dividing by would have been x plus 1. That's a little preview of the next section, no extra charge for that. But regardless, the point is, whether we did it synthetically or directly, we found that p of negative 1 is 8. P of negative 1 is 8. Alright, so you all try this one, letter B. Find s of 3 for s of x equal 3x to the 4th minus 5x squared plus 9x plus 10. Find s of 3 for that. Now, a little caution, 3x to the 4th, 5x squared. What are we missing? We're missing the x cubed term. If you're ever missing a term, you must account for it. You must account for it. So try this one on your own. Pause the video and try it. Okay, welcome back. So in the hoopty, we put whatever we're substituting in. That's 3. Then our coefficients, 3, and then 0, hopefully you remember the 0, negative 5, 9, and 10. Leave a little space, drop the 3, multiply 3 and 3, that's 9. 3 times 3 was 9. That came from the hoopty. 0 and 9 make 9. 3 times 9 is 27. 27 and negative 5 make 22. 3 times 22 is 66. 66 and 9 make 75. And 3 times 75 makes 225. So we get remainder 235. Therefore, s of 3, synthetically or directly, is 235. One way to check this very quickly, type this into your calculator, look at the table, and see if the ordered pair 3, 235 is on the table. You'll find that it is. Okay, try one with a fraction. We're going to substitute, that should be a positive 3/4, friends. So 3/4 goes in our hoopty. All right, I got 4, negative 3. Make sure they're all there. That should be plus 7x. Which, you know what, means I'm missing one. Who am I missing? I'm missing 0x squared, so we got to account for him. 7, negative 2. And let the fun begin. Drop the foe. All right, 3/4 of 4 is 3. That makes 0. 3/4 of 0 is 0. 0 and 0 make 0. 3/4 of 0 is 0. 7 and 0 make 7. 3/4 of 7, 3 times 7 is 21/4. Now, negative 2 is really negative 8/4. Add those, you get 13/4. 13/4. So, we can say that P of 3/4 is 13/4. That means the point 3/4, 13/4 would be on this graph, this graph, if you put it into your calculator. All right, and finally, example number 8. Now, here I've given you a binomial that includes the complex unit. We're not going to do this one synthetically. We're going to do this one with direct substitution. This is what you're used to. You've been doing this since pre-algebra. So h of 1 plus I is the same as 2 times 1 plus I squared minus 4 times 1 plus I plus 3. And just expand and simplify. When you expand 1 plus I, you get 1 plus 2I plus I squared. Notice what I did there was FOIL. You get that, guys? I wrote 1 plus I times 1 plus I. Distribute your 4, so that's minus 4 minus. Woo, look at me, I almost put plus. Minus 4I plus 3. Okay, now check it out. I squared, that's negative 1. Well, 1 and negative 1 just go away. Cross them out. See you later. Don't need you. All right, 2 and 2i is 4i. Combine minus 4 plus 3, that's minus 1. Minus 4i is sitting there. Well, 4i minus 4i, they go away. You just get negative 1. Check that out. That's awesome. So I went ahead and typed this into my calculator. That's what we just did. Now, be careful here. Make sure that you are in A plus BI mode after you hit the mode button. Make sure you're in A plus BI mode. Okay, so get out of there, second quit, and type it in just like you wrote on your paper in that last example, and looky there. Your calculator can work with complex units as long as you're in the right mode. And sure enough, it got negative 1, just like we got negative 1. Okay, that's all the examples I'm going to show you for section 1. Work hard, get off to a good start in chapter 2, folks. You got any questions, don't hesitate to ask me. I'm just a phone call or a text away. I'll catch you later. Have a great night. I'm out.